Quick Excel tutorial on how to perform a t-test. The purpose of a t-test is to evaluate whether or not the average of two sets of data, if the individual averages are actually statistically different, or whether the differences in averages, the actual differences, are due to the random error in the measurement of the universe. And so, for example, here we're tossing these rings towards a target and then measuring the distance from that target. We do that 20 different times, once with your dominant hand, once with your non-dominant hand. You end up with a mean distance away from the center. With your dominant hand, that's pretty close, 155 relative to 516 with your non-dominant hand. And we want to know, are these values statistically different or based on the distribution of these data sets that we could actually account for that difference simply due to the random error of the universe, meaning other factors that aren't actually due to the difference in the variables here, dominant versus non-dominant. And so to do that in Excel, you have your data here. You need it to be organized so that you have all of the data for the whole series, not just the averages and the means. Then you need to go to data from the ribbon, and under data over here under analyze at the very right, there should be a data analysis tool pack. If that is not present, then you need to install that. To install that, you'll need to add that directly manually. So you'll go to File, and then you'll cruise down to Options. And then when the Options tab opens, you'll go down to Add-ins. And then under Add-ins, there'll be a tool or analysis tool pack, which you'll select from this list. And then you'll click Go, and that will add this. You may have to restart the Excel software. Make sure you're running this not on Office 365, but in the downloaded version of the software. Okay, once that's installed, go to Data Analysis, and this is a pretty powerful suite of of formulas where you can do all sorts of basic statistics. So for more advanced classes, you can look at ANOVAs, we can do F-tests, histograms, Fourier analysis, but what we'll use in this class are t-tests. So there's 3 flavors of t-tests in this class. You talk a lot more about the nuances of t-tests if you take a statistics class or if you take a more advanced chemistry course like analytical chemistry with me, Chem 241. In this case, we want to do a t-test sample where we do not assume that the variances in these are equal. And that will be the case pretty much throughout the class. And so what we're doing, again, is evaluating whether these two means are statistically different in their significance. So I'm going to click OK, and that's going to give me a prompt where I need to input my variable ranges. And because I just did this, they're already pre-selected, but they'll look blank like this, and then this will be blank as well. So like anytime you are inputting variable series, you'll just click the arrow, and that will minimize this and allow you to select what you want. So select the entire data series for the variable that you want for your first average, and then do the same thing for your second average here. And then alpha here, we're going to leave as 0.05. Alpha is 1 minus what we think our confidence interval should be. So if we want our confidence, whatever we produce here, to be at 95%, then we'd use an alpha of 0.05. And what that allows us to do is determine with 95% confidence whether or not there's an actual real statistical difference between our mean values. If we wanted a higher confidence, we would decrease our alpha, say to 0.01. That would give us 99% confidence. So the output option will default to new worksheet ply. I like to just do output range, select this, and then just select some place in your sheet where you want the values to be produced, because it's going to produce a range of cells that we're going to interpret. Then you can click OK. And so this is going to compute this set of data. And so you have 2 columns here, variable 1 and variable 2, and then whatever the thing that was computed. So we have our mean that gets calculated. We already did that down here. The variance is related to the standard deviation, number of observations, etc. The details that we are looking at, the main thing is this t-stat. So t-stat is the value that's computed for our data. Then these two, t-crit 1-tail and 2-tail, are standard values computed from a table of t-values. So they're not unique to our data. They're just tabular data for the number of observations that we made. And so we're going to compare t-stat to the critical value, and specifically we're going to do that for the two-tail test. We're not going to do any one-tail tests in this class. And the comparison we're making is whether or not the absolute value of this t-stat exceeds that of the t-critical in a two-tail test. So our t-stat here is minus 1.8, and so the absolute value of that would be 1.8, and compared to the t-critical, it is less than that value. What that tells me is that the difference that we see in the means here is not statistically significant at 95%. So just to be clear here, because the t-stat, the absolute value of it, is less than the critical value here, we can make the assertion that the average distance away from the target center for the dominant hand versus the non-dominant hand, that average, which is the mean here, these two values, 155 and 516, they are not statistically significant in their difference at a 95% confidence value. 95% confidence value here means that there's still a 5% chance statistically that these two things are different for reasons that are not simply due to random error. And in other words, the difference that we're observing here, there's a 95% chance that that difference is simply due to the randomness of how the measurement was conducted, not due to an actual difference in dominant versus non-dominant hand. That's the assertion we can make. That's a pretty powerful assertion to make, because you may look at these two values intuitively and say, gosh, these things are so different. They are definitely, like, actually different, but statistically speaking, because the spread, the standard deviation, is so large for both of these values, what that indicates is that there's a lot of random error implied in these measurements, and that random error is probably the reason why these two things are different, not because you're throwing with a dominant hand and a non-dominant hand. So that's the utility and the power of doing a simple t-test here.